So by show of hands, before we get into it, how many of you, okay, come on, show it to me. Come on, there it is. How many of you have tried to deploy OSA already on your own? All right, so I got two possible, you thinking about it? No, you haven't, okay. So I have one person, okay. So if you don't know what it is, I'm gonna spend literally, if someone can time me, 5 minutes just explaining what OSA is and what the benefits and the features are. And then I'm going to jump right into more around the configuration and some of the other things. I do have some lab work to hand out that I can actually do now. So while I go to this slide, I'll talk about myself while I hand this out. So if you don't know who I am, my name is Walter Bentley. I am currently at Rackspace. My title is Senior Technical Marketing Engineer. If you don't know what that means, neither do I. I'm still kind of figuring it out. But that basically means is that instead of me being the architect, which is what I used to do with OpenStack, helping customers build OpenStack clouds, now I get to write about all the wonderful things that the architects can now use or provide to the customers as far as information goes. No? You want one? Oh, okay. Cool. So instead of actually being thank you. Instead of actually being the guy to help you design it, I just get to talk about all the fun things about OpenStack. I've been in IT for 18 years. I'm a New Yorksan, which basically means I am a New Yorker that just moved to Texas. I will always be a New Yorker no matter where I live. Sorry, it's just what it is. Cloud advocate, of course, OpenStack believer, and I love motorcycles, and these are just some of the places I've worked at. Twitter is probably the easiest place to find me, because I spend the most time on Twitter. I do also have a blog post, and I do have some stuff on GitHub that we're actually going to look at together here today. But you can look at some other stuff I have. It's all about Ansible and OpenStack in my world. So just some ground rules. I'm not going to ask you to turn your phone off. But obviously in this setting, usually I'm in a classroom setting where it's really important that everyone stays focused. So your phone can ring. I promise I won't take it. Biggest requirement is ask questions. All right, I need you to ask me questions. If you have something personal to take care of outside. And again, because we're such a small unit, you don't have to pair up into groups. I had enough labs for everybody, yay. The lab servers that you have will be yours for a week. So even after this is over, you can go back into these instances. They're running on Rackspace Public Cloud. You can use them. You can deploy OSA over and over again until your heart's content. They're yours for a week, all right? I've handed out the instructions of the student guide, and the reason why I'm moving fast is I want to make sure that I get as much of this stuff covered for you guys as possible. We will be deploying OpenStack as an all-in-one, right? So the instance, this test server I gave you that's on your lab papers, that's an instance running on Rackspace Public Cloud, and we're going to deploy OpenStack as an all-in-one. So it's not going to be fully distributed. Just to kind of demonstrate how you can do such a thing on a cloud, such as AWS, Rackspace Public Cloud, things like that, as a test and lab environment, of course. Never do that for production. And we will be working with the command line a little bit, and Ansible. If you're not familiar with Ansible, you're going to be familiar with Ansible before this class is over. You will be not an expert, but you will be very familiar with Ansible by that time. Okay, so deploying OSA. Very high level for those of us who've never really seen it before. It's basically the union of OpenStack and Ansible together. If you're not familiar with Ansible, it's a open source orchestration tool that's used to deploy and do any sort of level of change management when it comes to the actual instances, whether it be Linux, Windows. It has the capability of interacting with either of those systems. So it's in line with like a chef or a puppet, but just a different approach to it. And the idea is that Rackspace helped found the put together the deployments and the playbooks to be able to deploy OpenStack using a tool called Ansible. Right, so that's what we're going to be talking about today. I'm going to start at a very high level and then hopefully give you the groundwork behind it, and then we'll go right into the lab, because this is supposed to be more of an advanced lab when we're supposed to get more into the nuts and bolts. So I don't want to spend time with this stuff. We can talk about this stuff over a drink. Right, so really quick, OpenStack community adoption. It's basically the whole idea of deploying with Ansible. Kind of started around the time of 2014. It was something spearheaded by Rackspace. Got great reviews, and then at the Vancouver Summit it was decided that they wanted to make this an improved OpenStack community project, and that's how we kind of have what we have today, which is what we call OpenStack Ansible. It can be found at this GitHub location, so it's basically the GitHub under OpenStack. Really simple, straightforward. These are just some of the features and benefits that come with deploying OSA. So not only do you get OpenStack, but you also get Ansible, which to me is a two-in-one. Ansible is another orchestration tool that many organizations have found to be very useful. They were actually just acquired by Red Hat, so now they're actually part of the Red Hat umbrella, just as a small side. You also get the experience with LXC containers when you deploy OSA. You get full Linux, you get a Linux bridge agent, so you can basically get full-blown Neutron with this deployment. It can be used, it actually incorporates all core services of the OpenStack umbrella, as well as the other OpenStacks that we have approved to be production ready, right? So all the services aren't there yet. I guess one of the newest ones to start ramping up is Ironic with OSA. There's no Magnum yet, none of the more newer ones yet, but they're coming very, very shortly. And last but not least, the thing about OSA is that you can deploy it as an all-in-one, as a fully distributed. Doesn't matter how you do it, it's still the same set of playbooks and roles. It doesn't change, right? So unlike DevStack, which you're really only supposed to use for a development environment and can't use it for anything production, OpenStack Ansible, you can use it to deploy a development environment or fully deployed production environment. Doesn't matter, right? It's the same configuration. I mean, same roles and playbooks, just a different configuration that you have to tell it. And we'll go into that very shortly. Some of the high-level requirements about deploying OSA that you should know is that the baseline operating system needs to be in Ubuntu 14.04 right now. They don't have support for others yet. There is support for CentOS coming very soon. But right now it's just Ubuntu. SSH, NTP client, which we all know is required for OpenStack, and Python 2.7 or later, right? The bigger prerequisite that people a lot of times get hung up on, and I'm going to talk more about this part, is the networking features, the bridges and namespaces that you need to have in order to deploy OSA. They're not optional, right? You need to be able to create these namespaces and bridges on that bare metal machine where you're going to deploy it, or else you can't deploy OSA, right? So this, and you may say, well, why such a stringent requirement for a deployment model? And the reason for that is that in order to be able to provide a reference architecture that can span, whether it be from an all-in-one to a multi-distributed, it has to be able to have standard networking to rely on. And the way these bridges are set up and the way the traffic is split out is not only just for OpenStack operations, but actually for security and things of that nature. But again, we're going to spend a lot of time, well, not a lot of time, we're going to spend a good chunk of time talking about the network spaces and bridges that are required in order to deploy OSA. That's what most people get hung up at. So really quickly, if you have never looked at it, you can actually literally deploy OpenStack by either executing 4 commands, so these 4 different playbooks, or you can use the one playbook, right? So you execute that one playbook and it will go in and install all the prerequisites, HA proxy, set up all the infrastructure services, and of course deploy the OpenStack services, right? Really simple, really straightforward. And again, the playbooks are actually stored in this location. We're gonna actually look at it together, but that's how simple it is once you get the machine prepped and set up. The configuration in OpenStack or Ansible is actually done by 3 different config files, and then there's a set of optional config files that sit in a different directory. But it's basically those 3 configuration files that you would make changes to determine whether you want to deploy it as an all-in-one, you want to deploy it as fully distributed. You obviously need to give environment information such as IP to servers you want to deploy it on, different network ranges, and again, we're going to go over that together as well. So I went through that really quickly on purpose, so that we can get into some of the nuts and bolts. Before I proceed, is there any high-level questions about OpenStack Ansible anyone has so far?
Useful for upgrades or no?
Yeah, well, there is a set of scripts that you can use to do rolling upgrades with OpenStack Ansible. So that does exist. And that's something Rackspace created because that's what we use for our customers for private cloud, right? So we have a mechanism to do in-place upgrades. So basically you inherit that because that is a feature that we offer. Right. Everybody else okay? You're alive? You're awake? Yay! Exciting stuff, right? I know. We're true geeks. Can't help ourselves. All right, so let's get into some of the lab overview and things that we're going to go in, right? So we're going to start out very quickly and review a suggested node sizing and confirming the base operating system network setup. Then we're going to move into some of the pre-deployment Ansible playbooks and roles. Because the problem with OpenStack Ansible that I found that many people have is that it's not the actual execution of the playbooks they find to be difficult. It's all the work they have to get up to for the prerequisites for that machine that sometimes prevent them from being able to do the deployment, right? So knowing how to set up those prerequisites is key to a smooth deployment and something you can do over and over again. Then we're going to go into talking about how you make those environment-specific configurations, right, to make it where if you want to distribute it, fully distributed system with multiple compute nodes and multiple control planes, or if you want it just to be on one instance, right, or one server. We'll go through how to do that. And then last but not least, bearing we have time and bearing you guys have patience, we can kick off the build of that cloud. It may or may not finish in our session because this can take an hour, depending on the internet speed and things of that nature, right? So it may not finish, but the good news is if you don't want to kick it off here, you don't have to. You can wait till you get home, kick it off, let it run for as long as you want, and then you'll have a running OpenStack environment that you can play with. So I'll leave it to you guys to decide, but by the time we get to the end of the lab, all you have to do is execute one command and your environment will get built, right? So, all right, so let's all take a second. If you have a laptop, great. If you don't have a laptop, you just have to follow along with me. If you go to this is where I actually have the lab notes. So I'm assuming if you have a laptop, you can take part in the lab. If you don't, again, if you don't have a laptop, it's cool. Take that lab sheet with you, and you can do this remotely. You don't have to be here, okay? You can go anywhere you want. And again, I'll give it, those instances to you for a week, so you have plenty of time. So this is where I have the lab notes, and if you have a laptop and you're willing to participate, you can start by connecting an SSH to your lab server, and I'll start talking about node sizing while we do that. So I usually get asked a lot as to what are the recommended node sizings for deploying OpenStack using OpenStack Ansible. Well, the answer is there is no direct requirement in sizing. But some people are looking for suggestions as to how they should be sizing out their physical nodes. So I decided to just share with you what Rackspace does as far as how we look at sizing for whether it be a controller node, a compute node, and if you want sizing, we have sizing for block storage and object storage nodes too. I could share those with you as well. But this is just some baseline ideas as to what we use as far as sizing for machines. And then I also threw in suggested sizing for if you're going to use a cloud instance. Such as you want to deploy it on AWS just so that you can test it. You will not have a fully functioning OpenStack environment, right? Because you won't be able to create any instances that you can connect to because of networking reasons. But you can deploy all the services and test them out and do a lot of things of that nature. You can spin up instances. You just won't be able to connect to them, right? But this is just some suggested sizing as far as an instance sizing that you can use when you're deploying OSA, right? So it can be either way. Either one of those. And again, this is not hard set. You can choose whatever sizing you want. This is just what a basis reference architecture that we put out. So before we go into the next part, I'm going to basically go to this URL. And what this URL is what I'm going to basically demonstrate on the next slide, which is the network design and the namespaces and bridges that you need. So let's pop over here for a second. So, and let me know when this gets big enough so that you guys can see it good. Is that pretty visible? Sorry it's so left. I'm going to try and drag it over so that it makes it a little bit more. So what I wanted to show you here is that this is an example of what an interfaces file looks like if I was going to deploy OpenStack on a bare metal server. And I know you may say, well, I didn't join to talk about networking for Linux. But believe it or not, this is the piece of the puzzle that most people are challenged with when deploying OSA because they don't know how to create either the network namespaces or the network bridges that are created to deploy, right? I know this part seems so trivial, but this part is actually the most important part of it all. This is the part where even customers, when we deploy on premises, this is the problem we have, is that it's not set up right. Now, I'm not going to go line for line and explain to you the interfaces file here, but what I wanted to do is be able to show you the example of how you need to have those three bridges, the BR management, the BR VLAN, the BR VXLAN, the BR VLAN, and optionally BR storage if you're going to do sender storage. How these bridges are required and need to be created. And this is a live example you can use, right, of how to create those bonds. What's that?
Your BR VLAN, your provider network.
Right, so, and I'll explain these two, and actually that's a good question, right? So you may say to yourself, well, why do I need VXLAN and VLAN, right? And I explained the thought process around it. Actually, my next slide will actually help. It was a good segue into my next slide. Thank you for that. My next slide will actually hopefully explain it better, right? So this is what, when the screen comes up, this is what the network setup looks like for an infrastructure node, right? So for a controller node, this is what the network architecture looks like. And you asked a very vital question as far as the VLAN and the VXLAN, right? So the explanation behind this is that VXLAN, so everybody, may be familiar that VXLAN is basically a virtual network, right, interface. So basically, consider your VXLAN being a virtual network that Neutron is going to manage and create. It's not a real network that you can actually traverse over outside of the cloud, right? So consider that to be a tenant network, your VXLAN. Whereas the VLAN bridge is going to maintain the ability for you to use layer 2 networks, right? So with this interface, and I wish I could easily hop between the slides and my desk, but we'll just have to do it this way. For that interface, you'll notice that VLAN is not associated with any sort of VLAN ID. And the reason for that is that this bridge will actually can dynamically connect to any VLAN that's trunked or on that switch port, right? So I know, I see some people looking at me like, okay, now we've gone into talking about networking. And again, this is where most people get wrapped around the handlebars. That's why I'm spending the time here, is that this guy is going to basically be the means where you can connect to any layer 2 network, whereas this bridge is your means to be able to create layer 3 networks, which are just absolutely completely virtual networks. So there's distinct differences, and I'm happy you mentioned that question. Like for example, this VXLAN is attached to VLAN 20, right? Where you notice that this one does not have any bridge ports at all. Because whatever VLAN ID you give it is how it connects to that VLAN ID using this network interface. Again, if you don't want to get that wrapped around the handlebars when it comes to networking, you don't have to. Just know that whoever your networking guy is, give him this example and say, this is what it has to look like, right? Obviously, you would substitute out whatever your addresses are and whatever your DNS are. And of course, your interface names may be different. But,
one last question.
Sure.
And this is probably born out of ignorance here. Are you requiring bond to bridge, or can it go from interface straight to bridge?
Right. So if you're going to do this and use this for a production environment, we would recommend bonding, right? If this is total playland test environment, the bonds obviously don't matter, right? And I'm going to show you. I'll tell you, you keep leading me into my next slides. You do. I'm not making this stuff up. Now, again, I feel like I'm moving really fast, but the only way that we'll get to the gold, I want you guys to get to the gold. I got to keep us moving along. So I'm just going to flip back to this guy really quick, and then I'll show you another example. I'll show you an example of what it looks like if you were going to test it out on an instance, a cloud instance, for example, right? The interface file will look different. So again, I don't expect to break this down for you right now. I'm putting it here, which this slide deck is also where the lab environment is, so you can actually see this deck. It's already out there on GitHub, this deck. You can use this as an example to know exactly how your network needs to be set up, right? Just the most important pieces of the puzzle. Don't worry about the bonding. Worry about creating these network bridges, right? Making sure that they exist, right? And assigning bridge bond VLAN IDs to those bridges that you have to create. That's the key to that I was trying to drive home here. I know it's a lot, so just take in what you can. Compute node, exact same, right? You need to have the exact same. So you may say to yourself, well, why do I have to have VXLAN and VLAN on a compute node, right? The reason for that is that that's how Neutron is going to communicate with those compute nodes over those bridges as well, right? So these bridges aren't specifically just for infrastructure nodes. The network has to be set up exactly the same for your compute nodes, as well as your object storage nodes, as well as your sender nodes, right? They all have to have the same networking setup. So that was what I was going to try and drive home there. This link, it's another example of what it would look like if you were going to configure the interface for a cloud instance. Now, what you'll notice, is this getting cut off the screen? Yeah, it actually is. Okay. Well, there you go. It's like, why can't I see the end of it? What you'll notice is that instead of me connecting it to traditional like interfaces on a machine, I'm basically faking out this instance to use the one interface it has, right? The one interface network interface you're given on a virtual machine, and be able to use that and be able to create the network bridges off of that. That's above. Now, again, how do I got to this point? I don't remember. I think it was a mixture of stuff that Rackspace had did before me and trial and testing with customers, but this actually works. So this is actually a way that you can configure an interface on a cloud instance to actually be able to deploy OSA. Right. Again, you don't have to recreate this. This is there for you to use, right? So I did all the hard work for you. I'll expect payment through beer later. But I'm going to move on, right? So if you had stepped through the lab, all we did in section 1 of the lab, why am I wrapped? I'm always wrapped up. Okay. So step 1 of the lab was basically connect into a machine, the lab machine, and look at the interfaces file, right? So we didn't do anything special there. Section 2, which is the section I'm about to go into now, that's where the stuff that you really want to give me a big hug and say great things about me about, is I realized that when I went to go deploy OSA, and I do this a lot for customers, right? I used to deploy OSA multiple times in a day for customer demos, right? Whether it be just showing you Horizon or actually showing them like a DevOps demo. So I got tired to the point where I realized that chapters 2 and 3 of the instructions of deploying OSA are just pre-deployment steps, like literally. Like 2 chapters dedicated to all the stuff you have to do to the machine before you can deploy OSA. And quite honestly, I just thought that was ridiculous. So I just said, imagine if there was a world where there were Ansible playbooks and roles to do all the pre-deployment work as well. And guess what? Today's your lucky day. I so happen to have out here on GitHub, and again, all this information is there. This is the GitHub repo where you can find it. And I'm just going to hop over to it really quick and kind of just show you. Again, I'm not going to walk you through every playbook and role because that would be a little painful. But just kind of putting it out there that this is a repo that has it, right? So if you want to deploy Mitaka, basically all you would do is go into that RPC v13 folder, and you would see that there's a series. You would see it if it was on the screen, part of the screen where you could see it. Come on, there we go. Hey, you can see that there's a series of playbooks and roles that you can actually execute, and the instructions are in the root of the repo. And they basically tell you exactly what to do, right? So here's the setup instructions are here, and it'll walk you through. Make sure you have Ansible installed, clone that repo, go to this directory, edit these files. And at the very end, if you execute your build playbook, it will actually build that OpenStack server for you, right? So so you may say, well, why do I need this stuff? This stuff can't be that hard, right? And it really isn't that hard. But what you'll find is that in this playbook, I'm basically doing all the base setup. In other words, I'm installing all the base requirements, doing apt-get upgrades, doing all the stuff to the bare metal or base OS that you need to do. Then after that, I'm going to go in and configure any sender nodes, because for sender nodes, it has to have a specific volume that's created to be able to leverage that in that way. And at the very end, you're going to apply that network configuration that I showed you guys, and it's going to reboot your machine for you. Right? How much easier could that get? All right. The next piece of the puzzle is then there's another set of pre-deployment steps that you'll kind of go through in this guy here. And this guy would basically do prep deploy. And in prep deploy is where I'm actually going to, and I'll just show you that really quickly, and I'll move on. And again, if you're not familiar with Ansible, you'll get the flow. It actually is pretty easy to follow. And this is where I'm actually going to configure some more software, because there is more software you need, such as bridge utils and other essential Python things. I'm going to deploy Mongo, right? So you can do your Salameter stuff, because who doesn't want Salameter in their lives? And then I'm going to clone the repo, the OpenStack repo that I need. So it basically, literally, these scripts do all the work for you. All you have to do is keep changing this tag to whatever version of OpenStack Ansible you want, right? So I'm going to deploy 13.1.4, which happens to be Mitaka. If you want Newton, there's going to be a 14. I think there is already a 14 there already, all right? So all you have to do is keep changing that tag, and you pull down a different version of OpenStack right from their repo, right? Nothing tattered, nothing's proprietary. It will go do all the hard work for you, even turn on logging for Ansible, which you'll need later when you hit your build script, right? And the instructions, again, the instructions on how to do this are all sitting in the root of the repo. It's the easiest thing ever, right? So I've solved your pre-deployment problems. And not only have I given you the code to run on a cloud instance, I also have a repo in here to run on bare metal, which again, does very similar tasks. Bare metal is a little bit different. Why are you guys laughing? So I did all the hard work for you, I'm just saying. And it's a little bit different, a little bit different steps you need to do for bare metal. There's some more things you have to do, such as updating kernels and things like that. But again, there's the example of the interfaces file for bare metal is here as well. It's the same.
Is that for a particular version of Linux?
Right. So for this one, for Linux, so Ubuntu. Ubuntu. Sorry, no other. OpenStack Ansible doesn't support the other operating systems yet. They're working on it. Yeah, right now it's just Ubuntu.
That's kind of sad considering Red Hat bought them out.
Well, hey, that just happened, and because of that, it's gonna take a little while for everybody becomes kumbaya. Definitely recommend you using those scripts, those playbooks and roles. Those are there. They're not going anywhere. It'll save you and you can look at the role and see all the stuff it does, right? But just know that when you're done, you can deploy OSA.
That does bring up one quick question.
Sure.
1404 is bit, no higher, because 1604 you don't do cloud archive.
Right. So I think, I want to heard a nasty rumor that it is compatible with 1604.
Okay.
I almost want to say that officially that is the case.
Okay.
Yes, I'm going to stick by that one.
Okay.
So we're going to kind of move into the next phase of it, which is looking at that configuration file. So again, if you were following the lab, all we would be doing at that point is oh, I was right there. No, clicking too fast. So all we were doing is just looking at the playbooks and roles that are out there and kind of examining them. Section 3 is the part where it gets really a bit challenging for some, but we'll kind of talk through it. So step 3 is now, okay, so I've done all my pre-deployment work. Now I need to set up my configuration file so OSA knows how to deploy OpenStack, what services I want, what services I don't want, where I want them, how I want them split up, right? So if you're not familiar with this, there's 3 configuration files that are required in OSA, and then there's a series of optional, and we'll go through some of those really quickly, right? So the idea is that this is your most important guy, OpenStack user config. And what that file is used for is it actually will determine where you want to install Nova, where you want to install Docker, what nodes you want to be compute nodes, what are your IP ranges that you're going to give to do the deployment. What is the load balancer IP so that it knows how to configure your API endpoints, whether it be for public or for internal, right? All that work is done inside of this file. So this file is basically the map to your OpenStack cloud, and I'm going to show you an example of that. The user secrets file is really simple and straightforward. It allows you to set passwords for all your OpenStack services and things that need passwords, such as MariaDB, RabbitMQ, things like that. So this file is just basically where you put all your passwords. There's nothing special there. The user variables file is where you will actually turn off and on different things you can do in OSA. For example, if you want to deploy OSA with security hardening, you can turn that flag on to be true. You want to deploy OSA with Salameter, and you want MongoDB to be at such and such IP address, you would define that in your user variables, right? So things like that, as far as specific configurations of your OpenStack deployment, will be stored in this file. So I'm gonna flip over to these 2 URLs, right? This first one shows an example of what a OpenStack user config looks like for an all-in-one. And then I'm gonna pop over and show you one more of a distributed example. And the reason why I'm showing you that is I've seen people have a problem with understanding how to set it up when it's not just one machine. One machine is pretty straightforward. When you have multiple machines, some people kind of get a little confused. So let's go over and let's show that to you. All right, there we go. So if you've never seen this file before, it's going to look like a little bit of overload, but the key things that should jump out at you is as I mentioned before, having those 3 bridges and namespaces are really important because those bridges are reflective back to things in this file. such as that BR management bridge, is your container your container IP range. So whatever IP range you give for your BR management has to match this container range, right? Whatever VLAN you provide for your VXLAN network has to be on this network space, right? So consider this to be BR management. This is BR VXLAN. Remember, BR VLAN doesn't have, right? Because it uses whatever you configure in Neutron. And then that BR storage will be your storage, right? So the correlation is whatever IP range you define for your container network or your BR management has to be defined here, right? So there's a direct correlation of the two, right? The next thing that stands it down here is used IPs. You want to be able to set a range of IPs that OpenStack Ansible knows are used for other things, such as bare metal machines or just things you don't want, right? You've already consumed those IP ranges. So this is the range. I'm going to tell it from point 1 to point 20. OpenStack Ansible, do not use any IPs, because what happens is it's going to spin up containers and start utilizing IPs that are part of these IP spaces, right? So this is where you can define a block of it, tell it not to use, right? So these would be whatever IPs you're going to use to assign to the servers that are going to be part of the OpenStack cloud. You would exclude those in this, right? You would add those to that list so they would be excluded. I know a lot of people kind of get hung around that. This internal load balancer VIP address and external address. Just keep in mind that whatever you put here is what the API URL will be for whether it be internal or whether it be public, right? So the OpenStack services, when they're created, if you give it a load balancer IP address there, that's how it's going to configure the APIs in your OpenStack environment, right? And then remember, this one being your internal, and that would be your public URL. So just something to keep in mind. I usually configure this to an IP address that I'm going to install HA proxy, right? And an all-in-one, it would just be that address. And if I'm going to do a fully distributed, I would configure this to be whatever the IP address I'm going to have as a load balancer in front of my controller nodes, right? Make sense? I know it's a lot. Apologize, but I didn't create it to be that way. If you're going to scroll down, this network stuff is pretty standard. You don't have to touch anything in here in this block. Right, all this stuff is standard. The only thing I would recommend is that if you see network binding in here for a flat network, and you're not going to allow that to, so for example, you're not going to have a flat network option when it comes to Neutron. You don't want people to use flat networks. I don't think anybody really does anymore. You can remove that whole network stanza out of your config file, right? So that way it doesn't create it. And I believe that is what your problem is that it's creating a flat network type that is not bound to one of your interfaces, and the Neutron agent is not starting, and that's why you can't spin up an instance.
The newer Ubuntu doesn't use ENS something. We need to change the container interface to match.
Yes, you do. You in certain occasions you do. Like for example, this is a example of it on an instance. So this stuff doesn't matter, right? But if you're doing bare metal, yes, it will matter. Yes. Yep. Uh-oh. Guarantee that's my wife. Yep, it is. I should answer it and have you guys say hello. So, all right, so I'm going to go down to here. So again, this stuff is you don't usually have to muck with, right, for the most part. And again, a lot of this stuff here, and just so we're clear about this is the interface that it's going to define on the container that it spins up. This is not actually correlating to the interface of the bare metal machine. All right, I wanted to be clear about that. What I said was true still, but this is for the containers bridging networks, right? And the way they are going to be set up, not for your bare metal machine. So if I scroll down to the bottom here, you'll see that there's a lot of different types of hosts that are defined, whether it be the shared infrastructure host, OpenStack services host, storage host, right? So you need to define an address that's going to take on these, and see these as different hats, right? So shared infrastructure will be the machines that we're going to be running MariaDB or RabbitMQ, right? So that would be considered shared infrastructure host. Now, 9 times out of 10, you're going to put all that stuff on the same machine. You're not going to put them at all different places, but it gives you the opportunity to split out things, right? These are where the OpenStack services are going to run. They're going to run on that server. Sender API is going to run on that server. The repo server, right? So another thing about OpenStack Ansible, if you're not familiar with, is that you can define a repo server, which could be a server that may be the only server that can talk out to the internet, right? And what will happen is that the install will process and make the repo server pull down all the stuff from Ubuntu, or all the stuff from Ubuntu that OpenStack needs to build, and it actually will pull it. All the rest of your hosts will pull it from this repo server. So you don't have to have all your machines exposed to the internet to be able to deploy OSA anymore, right? Only one server needs to be able to get out to get the packages to be able to deploy OpenStack. So that's something to keep in mind as well. And again, there's more identity, there's more roles as far as what servers are going to be running Keystone, what are your compute hosts, right? So these are going to be the list of compute hosts that you're going to define for your OpenStack cloud. If you're going to do Cinder, this is how you would define Cinder as far as setting up this machine as to be a Cinder storage node. And then of course logging whatever servers are going to run your networking services, and then whatever servers may run HA proxy, right? Because there's also HA proxy playbook with OpenStack Ansible where you can deploy it, and it can be the load balancer in front of your infrastructure nodes, right? Again, I know this is like mind-numbing, but this is how you would set up if you're doing all-in-one, right? You're using the same IP for everyone, right? That's pretty easy. We're going to look at one where you're going to do multi-node. You'll see the difference, hopefully, and hopefully it'll be useful to you. Right. So the top part is exactly the same for a multi-node, right? It doesn't. This part doesn't matter. We still have to define network spaces, IP addresses that we're going to block off, a VIP address, right? All that stuff is standard. The bridge information for the containers are all standard. That stuff doesn't matter. What you'll notice here is that instead of defining just one machine, I'm now defining 3 to be my infrastructure node. I've defined 3 to run the OpenStack services, 3 to handle the Cinder APIs, right? I've defined 1 server to be my repo in this incident. I've defined 3 servers to run the Keystone services. I've defined 5 different compute nodes, right? So you can see the difference. It's not a huge difference, right? It's just how you define this stuff inside of that configuration file that matters. Right? And again, multiple Cinder nodes. This is how it would look if I were going to do multiple. So this is 2 Cinder nodes instead of just 1, right? So these are just, again, living examples, hopefully to kind of answer some of the questions about doing this deployment. I'm just, hopefully it's useful. I get a lot of questions, and I figured I would might as well put it out in the world. So at this point, if you were to log into your lab server, you can actually do the last section of the lab, section 4, which literally, and I'll show it to you, is executing a few commands to be able to get into the point where you can execute the playbook, right? So you basically would do this, these couple lines here, cd into OpenStack Ansible, cd into the playbooks directory, and execute this one command. And that one command will actually go off and build that current lab server with OpenStack. So I'll let you decide whether you want to wait to get home to actually execute that, or we can do one now. You tell me. So how many, whose environment didn't get used? All right. So I'll be number 13, and I'll actually demonstrate this for you. I'm not really good with typing with one hand. All right, I'm almost there. Can you guys see my screen okay? Okay. All right. So let's copy out one command and let's watch it go.
Have you ever thought about changing and set up everything to make roll?
Well, you know what? I will submit that suggestion in. But yeah, so basically what I did is I kicked off the install for the all-in-one. And again, it's going to go through those 4 series of the playbooks. The first thing it does is it preps the machine and makes sure that it has all the requirements, make sure that it has LXC configured and installed so that it can start creating the containers. It's checking kernel versions. It's doing, checking IP tables. It's doing all the prerequisite work. The second playbook then installs HA proxy, which takes 2 minutes. It's a very quick playbook. The third playbook sets up all the infrastructure stuff, so sets up my MariaDB, RabbitMQ, all the current tweaks that you need to have those things running. Elasticsearch, Kibana, like it is other tools that are part of OSA. So you get a whole logging suite, the whole elk stack gets installed. And then the last playbook will install all the OpenStack services. Again, we're not going to probably get to the last playbook of this thing because it takes a while to go through all the steps.
Are those the binaries or whatnot that's pulling in from, like, are they like devs or something like that?
So I believe a lot of the binaries or packages that are being pulled down are coming from whether it be Ubuntu or stuff that's coming directly out of Git that is in the OpenStack repo. But the repository server that you choose is going to store all that. So it pulls it down and stores it. And I forget where exactly all the stuff is kept. I won't lie to you. But you can look in the OpenStack playbooks, and you can actually see where it's going to pull the stuff down and store it. But again,
It's building some stuff there, so it's got to have like GTC or whatever.
yes. Mm-hmm. Yep. So again, I don't know if you guys, like I said, feel free to take the lab sheets. If you don't even have you didn't start it, that's fine. Take it with you. I'll leave them up for a week. All you have to do is execute that command and you'll have basically a fully running environment, but you'll have it more as a frame of reference too, right? Things you can look at. Use those playbooks that I created to do the prerequisite work. Trust me, they work and they save you a ton of time. Yes?
Unless OSA changes the app, your sources are all coming from Rackspace.
Well, yeah, we're one of the mirrors for Ubuntu. So yeah, that's the way it is. Yeah, yeah, we're one of them mirrors. So, yeah, Ubuntu. So I don't know if I had a few other tips and tricks that I just wanted to share with you real quick, and then I'll let you go, or you can go. I understand. So a few things that I've learned when dealing with OpenStack Ansible. First thing I'll always tell you is that when you're deploying OpenStack Ansible, use the tags versions, right? So you see how using 13.1.4 instead of master or instead of the one that says Mataka, right? Because they're there, but what you'll find is that sometimes when you what's that?
They're buggy.
They're buggy, right? Because they're the latest and greatest that was released of that iteration of that version, right? And there may be problems that haven't been discovered yet. So what my rule of thumb is that I always go at least 2 tags behind what the highest tag is, right? Because at least those ones they have worked through their problems and they've figured it out and they went back and fixed them. The newer one may not have those fixes yet. So I usually stay 2 behind. I use 13.1.4 for Mataka, it's fine. If you use 13.2 something or any 2 and above, you'll actually get Mataka, but you'll get the LBAS panels for Horizon. You won't get those until you get over to 13.2. But again, use the tag versions, don't use Mataka or master. That's the best advice I can give you. Check the GitHub repo every once in a while to make sure that any variables as far as configuration files have been added or removed, or if there's any sort of changes in setup. They do change the configuration files sometimes, they just do. So if you have an old one and you're trying to deploy the newer tag, it's not gonna work, right? So just pop in there and make sure everything looks the same. And I try to keep my code up to date as well. So they do change it. If you go back to my repo, you'll probably find that I've changed it too. Triple check your network setup. I can't say it enough. Your network setup is the beginning and ending of you deploying OpenStack Ansible. If you do not have it set up right, it will not install. Trust me when I tell you. You cannot trick it. You cannot go in and make changes to the playbooks and think that you're going to outsmart it. No, it needs those networks. So make sure your network is solid. Know that in the main playbooks folder, there actually are steps to clean up your environment. So if you go to deploy OpenStack Ansible and you find that it fails and you want to start over again, there's actually playbooks out there that will go in and wipe your environment clean. In other words, delete all the containers, allow you to start again. Because if you don't do those steps and you redeploy it again, it will create the containers again. And now you'll have double the mess on your environment. So just something to keep in mind. There are health checks to check Galera. And also when you're running OpenStack playbooks, there's something called -L. If you ever have a problem, let's say for example, you execute OpenStack Ansible and you have one node that just bombed out on some step. You can actually run that same playbook again, space -L, space the name of the machine that bombed out, whether it be compute 3, and it will only run those playbooks just on compute 3. It won't run it on all your servers again, right? So -L is your friend, all right? This is some more reference material. Again, the lab has already been put out. This deck has already been put out in the folder where the lab was. But there's some links here for some installation guides. And most and foremost, thank you for having me. If you have any questions about OpenStack Ansible or OpenStack in general, or if you just want to talk about life, feel free to hit me up on Twitter, or as well as send me an email. I literally have helped multiple people this week on installing OpenStack Ansible. So when I say that I'm willing to help you, I really mean it. I'm not just talking because that's what Rackspace pays me to do. So I really will help you. And if you need some more loving care as well, I'm willing to help you as well. Just hit me up on Twitter. Send me some config files, and I'll get you going, all right? But thank you guys. I appreciate it.